What exactly is network intelligence, and why has it become critical for keeping systems online? How are local data center power shortages forcing networks to stretch physically further than ever before? Is it true that AI demand growth is really calling into question the rule that telecom prices only go down? And finally, how close are we to reaching that ultimate utopia of a fully autonomous, self-healing network? Welcome to TeleGeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, Greg Bryan, and my guest today is Jezzibell Gilmore, General Manager of Service Provider at Kentik. In this episode, we're tackling those questions and more as we explore the explosion of AI workloads and how it's fundamentally changing the network landscape. We'll look at the realities of network complexity. Jezzibell shares her unique perspective from working across carriers, CDNs, and of course, co-founding the network as a service provider, Packet Fabric. We'll discuss how infrastructure is too often taken for granted and what the ramifications of that are. We'll look at the telecom price flip and these power shortages. We'll also look at the fascinating supply and demand dynamics that are happening right now. For decades, telecom prices have moved only in one direction, but there's these rumors of price increases on high demand AI routes, and carriers need to keep up with these AI changes to their traffic flows. We'll also tackle how data center power constraints and local pushback are forcing operators to build networks that stretch directly to distant data center sites, adding layers of physical and logical complexity. Finally, we also explore how AI is a double-edged sword, powering both advanced network operations and sophisticated cyber attacks. Jezzibell explains why true network automation requires a holistic understanding of the surrounding digital ecosystem, and how we are slowly building the foundation for networks that can process data and heal themselves at a level far beyond human limitations. There's lots more to cover in the show, and so I'm going to get right to it. But before I do that, I'll just say if you enjoy this episode, please take a moment to rate the show, subscribe wherever you get podcasts, and of course, tell a friend to listen. You can always find me on LinkedIn, and there share your thoughts, suggestions, and feedback. Okay, enjoy. Welcome to the show, Jezzibell.
Good morning, Greg. How are you?
I'm doing well. I was thinking before this. I think I saw you last at a conference in New York many years ago, so it's great to see you again. Yeah.
Absolutely. And
Yeah.
it's back in person. So I'm hoping to see you again in person soon.
That would be great. I'm looking forward to to this is a whole other aside, but enterprise networks conference stuff kind of fell off, but we've got some new things in the works, so I'm really looking forward to that. So maybe we can get you involved in some of those. So, yeah.
Absolutely. And, enterprise networking is becoming even more um, important these days with the rising of AI.
Absolutely.
And even though that we have these fantastic technologies and capabilities like we're using today, talking to each other from
Hmm.
afar, nothing beats face-to-face interactions.
Jezzibell, it's great to have you on. I know what you've been up to for many years, but could you give the audience a kind of review of your experience in the industry and all of the interesting things that you've done?
Absolutely. As someone who actually stumbled onto this industry by accident, I feel so fortunate that I keep having the good fortune of stumbling into opportunities that leads me to innovation, fun, great people. And after I had spent a good 10 years with Packet Fabric. Obviously, I started my career with companies like AboveNet, Akamai, and Server Central, GTT. Um,
Hmm.
I I actually started, as you know, Packet Fabric with a few friends. Oh my God, more than a decade ago. Uh,
When NAS was hardly even a word out there, right? And it was a really new idea, which is I think really cool. Yeah.
Yes, and I won't name names. One of my previous CEOs asked me, um, why would you want to do that? Who would buy network capacity from a website? Uh,
Mm-hmm.
so, but seeing the success of automation, networking, and seeing the the growth of uh, AI and
Hmm.
uh, additional necessity to help us to optimize networking so we can reach additional efficiency to support the criticality of the workload that network is supporting. I've recently, as you know, joined Kentik,
Hmm.
which is a network intelligence platform. So, moving from network as a service at Packet Fabric after a decade to network intelligence is actually a choice.
Hmm.
It's
Hmm.
something that I find to be extraordinarily necessary for this time with the development and adoption of AI.
Yeah, absolutely. And I love that you were able to bring to this conversation that perspective of understanding what it's like at a carrier, understanding what it's like at a CDN, understanding what it's like at a network as a service, and now on the network intelligence end. I think that really kind of like brings together a huge piece of the network pie. So it's great to have you on. So,
Thank you.
Jezebel, what I want to start with is how this whole series that we're doing is about AI and the impact on networks. And as I've often said, there's two aspects of that. There's how networks are impacted by the growth of AI, and then there's how AI can facilitate better networking. Right. So let's start with that first one, the sort of the strain that AI might put on global infrastructure. I think for so long, even folks within our industry, but especially in the tech world, the network is taken for granted, right? So, when folks are working on AI or whatever new tech thing, it's just okay. Well, we'll just draw a cloud on the diagram here, and that's where the network is, and it's just there, right? So, but in a way, what's happening with AI has forced networks back to the forefront, making people think about this again. How do you see that unfolding from your perspective?
Absolutely. I think, what's truly interesting is AI was sort of seen as a utility for
Mm,
quite a long time. Sorry, networking was seen as utility for quite a
hmm.
long time, right? Until AI came along and GPU workloads became so expensive and so critical, and people sort of forgot about networking.
Right.
And hence, in the last decade, I think what we have been watching is the continued compression of pricing
Hmm. Hmm.
and increase of volume
Right.
and the diminishment. I'm not even sure if that's a word
It works as long as we know what you mean. Yeah.
of um, of networking, right? Of physical infrastructure and even digital infrastructure in
Yep.
support of everything else that we are consuming through whether it's social media, streaming content, or anything else, such as video conferencing, right?
Right.
Something that we take for granted. Can you imagine if there weren't video conferencing during the time of COVID? How could we have gotten through, right?
I have often said that if COVID just had happened just a few years earlier, I think the impact on the global economy would have been very different because of compression and Skype having been around and streaming making ISPs boost their end user networks and whatnot. We were actually in a pretty good position to handle all that. It's interesting luck.
For sure, right? And to me, I felt so fortunate that we had built most of the infrastructure for Pocket Fabric back then. So, we had a way to help our customers and, anyone who needed physical infrastructure instantaneously to turn up capacity back then. And if we didn't build that already, what would happen? Like,
Yeah.
people wouldn't be able to get into data center to turn up circuits. So that was really fortunate. But coming back to the topic that we're talking about here, I think that AI is exposing the criticality of physical infrastructure.
Hmm.
And so many people overlook the fact that there's a physical element of networking, and the physical element and the logical element don't come together easily, and they are quite diverse from each other. And the ability to make network actually operate smoothly is
Hmm.
a lot of it's a combination of a lot of different technologies, and it's super complex. The more that we add onto it, the more we use it, the more complex and the higher the capacity we need, the more complexity we put into
Hmm. Yeah, that's a great point. I think again, too often people think of network operators as kind of like plumbers in a sense, which there's something to that, but it is so difficult and complex, not just in terms of where the network is physically located and what kind of medium it's going over, but how you gather and use information about everything that's going on in the network. I think you said at the beginning network intelligence. I will say that I'm used to thinking of what Kentik does as monitoring, but I think intelligence is a much better way to sort of put that. When we're talking about AI, maybe we separate that into the two main impacts on the network of AI are different, whether you're talking about training or usage, like inference. How do you think network intelligence is playing a role in sort of facilitating that, given all this complexity and difficulty on the network side?
Well, if you think about what is network intelligence, and I think that's the question everybody's asking, right? What is
Mm,
network intelligence? This is fairly new, and Kentek used to call itself a network observability, but we do so much more than just observe. And observe, when you observe something that feels quite passive,
mhm.
right? And the network today requires so much more than somebody watching from the sideline, right? The data has to be actionable, has to be turned into actionable insight. So when you take observability, performance monitoring, and enrich that data and use the knowledge and historical knowledge as well as the predictive data that you put together over time, you can give a holistic picture of the network, right? That
Mhm.
allows digital infrastructure operators, right? That includes enterprise cloud providers, telecom operators, to analyze and optimize and provide real-time visibility into through their network traffic, um, and infrastructure performance, cloud performance, internet connectivity globally, to give um, improvement and reliability, security, and operational efficiency to a network. Right? That's what I think network intelligence is, because
Mhm.
it's for most people it's really hard to quantify, right? It's
Right, right.
but it's just as important as business intelligence, and
Mhm.
that's something we, I think, as an industry, haven't had. I mean, imagine that. Like, how long have we been using CRMs? Right, we
Right.
have customer intelligence, we have business intelligence, um, but we've always had network, but we actually never use that data to extract real intelligence in understanding the network itself, the traffic behavior, and to help us actually run the network better.
Yeah, that makes perfect sense. So I like to think of it in a way of when let's say your AI companies are coming up with, it's still unclear to me what maybe the enterprise killer app in AI is going to be, right? But when they're thinking about this, they're thinking purely about, okay, so what business problems are we solving with this tool? How are people going to use this to be more efficient and that sort of thing? But the way that I see the world, right, it's always comes back to, okay, well, the the network has to be ready to make that tool actually work and do the actual tasks that they're hoping enterprises will need to adopt. Otherwise, no one will adopt it, right? They could be the coolest tool in the world, but if you can't get it to actually run on the network as you have it right now, you're pretty quickly going to leave it behind, right? So,
In order for AI to become really fully leveraged in networking,
mhm,
maybe we're not quite there
right,
100%. If you're just basing your education on the trainings of the Cisco's, the Junipers, right, all of the large hardware vendors, because they're the ones that's putting out a lot of the training materials on how these are the boxes work,
right,
and this is how you should be setting up your network. But if you did it, nobody does it exactly that way because
mm-hmm.
why? Why is that, right?
Yeah, I don't know why.
Because nobody has the luxury and of building a network greenfield with all new hardware today. So how did the
Absolutely,
networks
yep.
come together? They come from years of piecemealing, mailing the different pieces of network. I mean, if you look at someone like Lumen or Zayo, right, North America, or Colt, or BT, the networks didn't come together as one single deployment. You didn't
Hmm.
buy, 10,000 Cisco's. I'm sure Cisco would love that though.
Yeah, yeah, yeah.
Didn't
I mean, Lumen's a great example because they, as a company, it's had so many iterations. Level 3 and Quest and Global Crossing, and so, and all those get kind of kludged together, right? So yeah,
ab- absolutely CenturyLink and Savas, right?
yeah,
So you're basically a big melting pot of a lot of different network that's run differently coming together. You can't, I mean, is your first order of business when you merge these businesses and saying, oh, I'm going to go swap out all the routers here
right.
in this
Hmm.
network? No, right? It's running. So now you got to be able to have two different networks that are run on different types of gear and with different architecture put in together as the same network. And then
Hmm.
they have different OSS, BSS. So then you're all of a sudden running two OSS, BSSs for one
Right.
single network, similar to GTT, who I personally have had the experience. I think there's, over 30 different networks that got really quickly put into one over the years. So,
Yeah. Wow. Yeah.
right.
That's a nightmare, really. So yeah. Yeah.
And you got to give kudos to our engineers, the
Hmm.
operators of the networks, to really having a handle on putting these networks together, having their hands wrapped around the network super quickly. And and I think that's where Kentik really shines, right? Because it's a ubiquitous tool that allows you to see your network through traffic, through telemetry,
Hmm.
of so many different kinds, and pulling all that data together at above human intelligence level, right?
Right. Right.
Uh, uh,
That's key. Yeah. An engineer sitting in a knock, might have a lot of difficulty, I imagine, sorting the signal from the noise when there's hundreds of alerts all over the place and which ones are actually a problem and that sort of thing, right? So,
for sure, but humans can see alerts, right? I can maybe read like eight different alerts trying to figure out, oh my God, so what's broken? But I can't read the raw data.
mm-hmm,
Right? I'm
hmm,
human. I like when I can look at the graph and get a gist of what is going on.
right.
but I can't look at all the raw data and coming up with something. And not to talk about a network and a network operations centers engineer, right? Is because NOC engineers are great, and some of them are quite senior,
Hmm.
but a lot of them are fairly new entering into the infrastructure industry. And not to call myself old or call you old, Greg.
Yeah, that's
Like,
well, yeah. Everybody can see the gray in my beard. It's sorry. It's
well, it's all of us, right?
yeah.
But a lot of us, I have a lot of personal friends who's, you know, going into retirement or pseudo retirement.
It's a great
And
point. Yeah.
those are the industry experts that used to be able to look at some of the raw data and says, okay, that does not look right. And that's
Hmm.
based on 20, 30, 40 years of experience,
Right.
right? And when you have someone who's entered into the workforce, 3 years ago or even 5 years ago, they, they're not used to be looking at data like that. And they're used to be leveraging tools to support them, right? When you're
Hmm.
in business intelligence, when you're on the marketing, the sales side, you used to have really sophisticated tools to tell you, you know, this and this together, or these six things together means X, Y, and Z, and you should potentially be doing that. We don't have that on the network operations side, right? We didn't have that until Kentik came along, and
Hmm.
and until really recently, um, especially started last year when Kentik was able to leverage AI to
Right.
run across all of this data to give like quick summary and actionable insight in saying, we're looking at these data and this is what we think is going on, and then giving you the access to the actual data, to places, because for engineering, maybe you don't even know where to look, right?
Right.
Or if
Right.
you think about looking at two different places instead of five, and but it's really the combination of those five to give you the real understanding of what is happening and why things are happening on
Hmm.
your
Hmm.
network, right? It could be a port that's failed in Kuala Lumpur that you didn't realize that's impacting, right? Because of that traffic that's supposed to go over there has to be redirected somewhere else. And that is now congesting your peering in Singapore, right? And or you're upstream, and then you're seeing carpet bomb attacks from somewhere, which you didn't know that was happening, right? Because they're happening so quickly and so short these days.
Right.
So, um, you know, as much as AI is able to help us run our network, they're also helping the attackers to run their attacks, right?
Great
So,
point. Yeah.
people who
Yeah.
are leveraging AI to do things that's helping you are also helping the people who are doing things that is impacting you, just like your customers. You're like, oh, my customers are asking for 8 times more the capacity they did last year,
Hmm.
right? But they're also asking not just for additional capacity, they're also asking for increased response time, reliability, right? It, think about, okay, so if I can't get to see my Netflix video,
Hmm.
but if I can't work, that's even more urgent, right? Because so much of what we do is remote and requires connectivity. But imagine that if you're running AI workloads, that's impacting for your manufacturing, for your, you know, manufacturing floor. All of a sudden, hundreds of thousands of dollars per minute is piling
Yeah.
up. That can't happen.
Hmm.
Or even worse, if you have, autonomous vehicles, that's requiring some sort of AI to provide feedback. maybe my imagination today isn't
Mm.
wild or crazy enough to see what we'd be leveraging AI for
Oh,
tomorrow.
I say that all the time because I think that's one of the things that's going to be a challenge for the network industry, right? Is that it's not yet clear what AI actually ends up being for particularly the enterprise customer and consumers as well. And to some extent, I think there's two dials that carriers have, which is bandwidth and latency. Of course, it's a lot more complicated than that, right? But that is this an application that eats up lots of bandwidth? Is it an application that needs very low latency to function properly? I think like autonomous driving is a really good example of that. That adds like a third vector, which is that you need the requisite bandwidth and you need the requisite latency, but you also need that to be moving across the network in real time as well. And so it's hard to see now, but it seems like very much that AI has the potential for sort of rewiring the network, if you will, right? Kind of literally in a sense, or recentering the gravity of the network, right? In ways that we don't necessarily see yet, right?
Absolutely. And I think the other day I watched a documentary on um, humanoids and the different types of humanoids that are available.
Mm,
And um, my assumption on how far the humanoids was available, had technologies become, is far behind the reality. I
hmm
think I
hmm
watched a humanoid doing some really crazy kung fu moves, and
Yeah,
it made me think of Matrix. And
yeah,
I was, I was like, oh wow, that's like Neo fighting. Because if I got into a situation with a humanoid, I certainly wouldn't. I don't know kung fu. Uh,
right, yeah,
you know,
yeah.
I and but that is only a single aspect of how um, AI can be utilized today,
hmm
right? I think we are at a juncture where our intelligence is no longer the superior intelligence
hmm
today. I think
Which is
for a really long time, no, we were.
yeah, scary to think about, but there's also like some incredible possibilities, right? So
For sure. And hopefully, our imagination and creativity is still superior, and that allows us uh, to be more. Right?
yeah, absolutely. But that's that Jezebel. It's a really good point that thinking about like if you have autonomous vehicles or even like humanoid robots, I think that the way that we as humans always envision that um, in science fiction, let's say, right, was very different than what the reality be. And what I mean by that is that if you go back to like Asimov, like iRobot, that sort of thing, like each artificial intelligence was just an entity unto itself, or HAL 9000 in 2001. It was the idea you just get enough transistors together and you have an intelligence. When in reality, everything that I'm aware of being built and utilized in AI is actually doing the thinking back in a GPU in a data center, right? So it's all about moving bits across. There's not this isolated intelligence here, even those humanoid robots are connected to the network, right? And getting and processing information over the network, right?
Right. I think the the compute efficiency in silicon today has
hmm
improved incredibly from the past, but it's nowhere in what we see um, in the science fictions, and it doesn't
Exactly.
compare to human intelligence, right? Like
Right.
the amount of power it requires to process a single thought that we
Right.
would, right, as a human, requires thousands of GPUs inside data centers,
Which gives you a
right?
lot of appreciation for our brains as a result of evolution. That like we do incredible things when you think about it. Yeah.
For sure, right? And it gives you actually more appreciation for our bodies and our capabilities. And network, the networking that we talk about, that we run, and I embrace and I appreciate so much, is basically the neurons that's inside our body, our nervous
Hmm.
system, right? And so imagine that if you don't have a nervous system, you don't have the neurons to transmit the data across, like what's the usefulness of all that processing? So
Right.
similarly, in going back to uh, network, right, the explosion of AI workload, GPU, data center traffic has made networks so much more complex and bandwidth intensive,
Hmm.
right? Like
Hmm.
I think that how I'm hearing about the needs from the networking, um, I I thought to myself, wow, I'm glad that I'm not a network operator today,
Yeah. Yeah.
right? Because
Yeah.
I'm like, oh my God, like the just hearing about what people are asking for, right?
Hmm.
Um, we have customers who run uh, neoclouds. They have 100% SLA to their customers
Right. Yeah. Like
for because GPUs are
me.
so expensive still,
Yeah. Exactly. Yeah.
right? And so the impact of the availability of those workload is measured on, per milliseconds. Like,
Hmm.
because I think that when we're looking at things, we're like, oh, it's three nines, or two nines, three nines, four nines. But they're like, we guarantee 100% availability.
Right.
So,
Yeah.
but if the customer can't get to the GPU, then that is not necessarily our problem. We have to
Right.
people, they have to also be able to prove the state of innocence and to show the customer how. But they also want to do their best, give their best capabilities in making the GPU clusters reachable
Hmm.
through,
Hmm.
various.
It's a great point, and you touched on this, I think, a little bit earlier, but I don't know if we could go a little bit deeper on that. From obviously, a lot of folks listening to the show are from that side, from network operators, right? And so, hearing this, I'm sure a lot of them are like, oh yeah, this challenge, this one, and it kind of goes back to a challenge that's been in the industry for a long time, but I think being made sharper by the AI boom, which is that on the lit services side, prices are always going down, right? So customers expect to constantly pay less for every wavelength that they put between data centers or whatever, or their DIA connection to their GPU, Neo clouds, whatever it is, right? And at the same time, that availability has to be constantly increasing, right? That the mean time to repair has to be getting close to zero, right? The all of those things have to be improving and handling these bigger workloads and all of that. So, does networking intelligence sort of play a role in balancing these equities, right?
I think in a way, for sure, right? Because all of that means we used to talk about the three aspects of what everybody asks for in networking, in network operations. You want your capacity, right? How much
Hmm.
traffic you can push through. You want to have the reliability,
Right,
and you want to have the cost effectiveness.
right,
And I would say those are the three things that you can have, and you can only have two out of the three,
right.
right?
Yeah,
Like you almost,
it's the
oh,
old good, fast, or cheap, right?
right, exactly.
Yeah. Pick two out of
So
three. Yeah.
that's right. This year, just recently, I have heard that there's price increase on services that one of my very good friends said, had I known what would happen, what is happening now, 2 or 3 years ago, I would have never sold services at the prices that we sold them. If you're looking for something very specific, the price is actually increasing, not
Right.
decreasing. And
Yeah.
I think that's also important when it comes to, there's a demand, supply and demand issue. There
Right.
in certain areas, there still are a lot of supply, but in certain areas, there's a lack of supply now because there's such high demand, number one. And if you're looking for all three elements for, reasonable pricing, one of them's going to have to cave a little bit or
Right.
a
Yeah.
bit, quite a bit. And people are no longer willing to compromise on the capacity or the performance. So
Hmm.
where they're caving is on the pricing. And so you start to see an increase in price for network services.
Yeah, I mean that's really interesting. And been doing this a long time, and at any given time, if you had asked me, it's like the answer is telecom prices always go in one direction, and that's down, right? But indeed, and I'll say the geography part and telegeography is important, as I always say, right? That this story varies a lot around the world. What's the competitive landscape? What's the supply
Mhm.
look like? What is the demand for that particular situation? But I think it's going to be really interesting to watch, especially because you have like price inflation constantly on the data center side. You know what I mean? That there's just there's only so much power that's like start there, and then so people have been dialing in their plans to think about that. Like, okay, we're chasing not just power cost but power availability now, right? Um, but again, then there has to be a network there that has to have the kind of capacity and performance that's necessary for these workloads, and that's going to come at a price. You know what I mean? So, they're we we'll move to 800G waves and 1.6 terabytes and things like that, but even still, it's going to be interesting to watch if AI is kind of behind a big enough boom to finally take care of that. Like I said, for years in the industry, it's always been, well, my prices are constantly going down, but the amount of bandwidth, is kind of keeping pace with that. Now we might see the bandwidth sort of exceed that and actually see some changes in the industry. I think that's going to be really fascinating.
I always, I often, not always, I often find technology challenges are easier to solve than human challenges.
Interesting. Yeah. What do you
Right.
mean by that exactly? Yeah.
There's
Yeah.
physical limitation. Um,
Right.
like you can't change the speed of
Right.
light, right?
Right.
So
Right. Right.
sure, I, you know, but can we um, do something to reduce the processing on the router side so that we
Hmm.
gain
Hmm.
an extra
Hmm.
millisecond here or there?
Right.
Possibly, right? And
Yeah.
those are the things that we continue to work on. When it comes to power shortages, can we increase our generation? Are there clean source of generation available? Yes, right?
Right.
We all
Right.
have heard of nuclear power generation. It is a lot safer than most people understand. I think there's a lack of real education around that. But at the same time, it's not that technology isn't available. It's the fact that it's the humans that don't want to have the power generation in their neighborhoods. In
Great point. Yeah.
fact, I think there's a real negative pushback on having data centers in people's backyards.
Big time. I mean, it's in the news. I live in Northern Virginia, so it's in the news here every day, basically. Yeah. So yeah.
Right? And so now we're just adding additional complexity to networking
Hmm.
because people are thinking, okay, well, I can't put it in people's backyard anymore. Like it's no longer, we can no longer put suburban data centers in suburban areas. We have
Hmm.
to put it near the power generation, which is quite far
Right.
and from where the inferencing needs to be,
Right.
right? And all of the GPU, the actual GPU processing has to be in the core, which are, somewhere that maybe that's what you're trying to build, right?
Hmm.
To
Hmm.
for additional processing, training the data. But then you got to be able to get to the inference, or the inference has got to be able to get to the core.
Right.
And so now you're creating additional complexity in networking. So what
Hmm.
is going to make the compromise? Because it's not the power, it's not the humans, it's not the geography. So what's making the compromise? It's the network.
Right.
Right now, all of a
Right.
sudden, you're like, okay, got to stretch your nervous system to reach that further, right? Because now the data is actually a lot further for you to get to. But again, we can't change the speed of light. So you're not going to be able to change how quickly you're going to get the data from one place to another. So the only thing that you can do is to really optimize your network as much as you can, right?
Yeah, that's a
Because
great point. Yeah.
the route
Yeah.
mile is still going to be there. So then,
Hmm.
how do you now? Everybody's got to focus on how do you reduce the latency
Right.
given the distance, right? Which you can't change,
Hmm.
and and everything else, the optimization has to come down to basically everything else. So you can use AI automation, to reduce, to help detect anomalies, to predict issues, to help you troubleshoot faster. So you don't, you can resolve your outages faster, optimize traffic routing, your peering situations through analytics. You know, the platform, that Kentik provides can help you do all these things, and you are going to need it so much more now
Hmm.
because of all these other limitations that's being added to your infrastructure needs.
Right. Yeah, those are all great points. I think to put a pin in a few things. One, I think we sometimes think of the training piece and the inference piece as just these two separate challenges. Training moving huge data lakes around the world to different data centers, and then the inference part getting to your GPU as a service or neo cloud or what have you. But also, you're saying there has to be communication between the inference instances. That's hard to say, but yeah, and the where the models are being trained, so that they can continually be updated, and so creates complexity there. And then I also really like your point about, we can't change the speed of light. There's physical limitations here, but then there's also embedded within that, not just the physical distance of the route miles, but what is the traffic situation along that path, right? So I might find the lowest a number of route miles for my path, but that's a really crowded kind of path, and there's going to be a lot of traffic jams at every router, basically, right? So there's a lot of things to balance, right?
That's right. And, maybe the router that you had a private network interconnection, right, at a location. That's how you normally send traffic, and it's the shortest route and maybe more expensive, but you've been able to provide really great um, performance to your customers.
Hmm.
So,
Hmm.
but that particular box is having a card issue, right? So
Right.
all of a sudden, that port is actually uh, losing traffic. So
Hmm.
your performance is no longer good there because so you have to now go through a longer path that may give you actually worse performance, but it's cheaper. Like it could be going through a
Right.
viewing port, but if you have very important customers in that location, that needing data from that location, you're like, I don't care if I'm spending a little more extra money
Hmm. Hmm.
for this, but I need this to be back up. So now you're like, well, now I have to look for a tertiary alternative, right? Just like
Right.
I don't want to just have my primary connection and my peering. Now I need to have maybe a secondary upstream that allows me to connect to them, or a secondary, a tertiary route that in case that my primary fails. So
Right.
we were actually talking to someone and one of our customers, and they say that we always have four diverse uplink in any given location.
Wow. Yeah.
Um,
Yeah.
that's how critical
Hmm.
the infrastructure is. Do you know how hard it is to build four
I was gonna
diverse
say, I like even
links?
just like thinking about that. Like, one, there's obviously costs with that, but two, that comes down to a lot of information because ensuring diversity is difficult, right? You know what I mean? Just like, do you really have the specific like KMZ files, or, you know what I mean? So that's a big challenge to itself, right?
But what's interesting, you just mentioned, and most people think of this, right? When you buy services, network services, you think of KMZs. That
Hmm.
is absolutely the physical layer, and it's really important. It's like, yes, I want them to be on diverse network path,
Right.
but the path is not just physical. The paths are sometimes logical, which
Ah,
means
yeah.
that sometimes you're traversing the same router even if you're on diverse path.
It's a great
So
point. Yeah.
then if the router encounters problem,
Hmm.
right, then all of a sudden you're down even though that you're supposed to be on diverse path anyway,
Right. Yeah. Yeah. Yeah.
right?
We think of the world often in this like physical sense of, when the network goes down, there's somebody ran into a telephone pole, somebody dug without calling miss utility. But you're right that there's all of those bits are hitting equipments that have failures, that have traffic jams, all that kind of thing. Yeah, even if you have all that sorted out, that's I mean, it's a difficult job, isn't it? Yeah.
So much more complex than the way that people talk about it. We always
Yeah.
try to simplify when we talk about it because otherwise we'd spend all day talking about network
Right.
operations. And I
Yeah.
could,
Of course.
it's,
Yeah.
I could spend all day
Yeah.
talking about network operations.
Yeah.
It is absolutely a passion. Um, but even when you buy diverse path, when unless you're actually operating the
Right.
physical layer yourself,
Hmm.
um, when you buy a wavelength service, a service provider could easily groom you
Right.
from a diverse path onto, a overlapping path, even though you're from the same service provider onto the same
Hmm.
path, onto the same
Right. Right.
equipment,
So you
right?
need to be
Just,
aware of that. Right. Yeah. Well, Jezebel, we are running out of time, I'm
oh my
afraid. But
goodness.
yeah, but I always want to make sure I ask my guests, what do you see coming that's interesting? So even if we look pretty near term, given that it's very difficult to see exactly how AI is going to unfold. What do you think that in terms of network intelligence, you would really want sort of network operators, both from the end user side as well as the operator side, right? Folks managing networks. What do you think that they should be expecting to see and being really focused on in the next year or so?
Well, I think that the utopia is to have a fully autonomous network,
Mm, absolutely.
right?
Yeah.
So, who doesn't want a network to be self-healing, self-repairing, and um, that just does everything that we would do as humans to make the network and to scale, right? And saying, oh, I'm running out of capacity, let me provision additional circuit over there to increase my capacity. But the world isn't set up for that just
Hmm.
yet, right?
Yes.
Um,
Yeah. It's going to take a lot of work. Yeah.
yes. And I think that we're working towards that.
Hmm.
Um, but the automation, autonomous network requires data to be able to operate
Right.
autonomously.
Mm,
And
great point.
which
Yeah.
means that, and the data is, has to be consumed. Um, your data, because you only have access to your own data,
Right.
right? But you can't make a decision just in a vacuum for
Mm-hmm.
autonomous. That's like saying if you want to have autonomous car, right, vehicle, that it needs to be aware of what else is happening on the road, not just
Right.
what's happening with the
All
car.
all the variables. Exactly. Yeah. Yeah.
That's correct. So, in order for a network to be autonomous, you have to have the wherewithal of what's happening in the surrounding network that you're
Hmm.
interacting with.
That is fascinating. I love it. And I think lots for folks to unpack there as we sort of try to work toward that future. Jezzibell, how can listeners keep up with you and your work at Kentik if they want to sort of follow along?
Come to kentik.com. That's Kentik. And if you have any questions or even any objections to what we talked about today, right, I'm happy to continue to discuss and learn from what you have to say. I am reachable at Jezzibell@kentik.com. So feel free to reach out anytime.
Excellent. Yeah, I always say, I tell people who listen to the show, like, find me on LinkedIn. Tell me what I said was wrong. I want to learn. Right. So yeah, absolutely.
Absolutely,
Yeah. Yeah.
absolutely.
Excellent.
I think life is a learning experience.
In fact, I have a kind of saying about this is that the more certain someone is about what's going to happen in the future, the less inclined I am to believe them. Right. So, yeah. It's because, just like the internet, I think, um, how all of this AI, both as its utilization and as its impact on our industry, I think unfolds is going to be moving in some unexpected directions, right? So I think what we have to do is how can we set ourselves up best to be prepared for unexpected things to happen, right? So yeah,
Absolutely, Greg. It is a pleasure. Thank you very much for taking the time, and thank you for such a great discussion.
yeah, likewise. Cheers.
Take care.
Thanks for listening. TeleGeography Explains the Internet comes from the experts here at TeleGeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.